So this is our last part of chapter 12.2. We're going to be talking about stem and leaf plots and a few other types of graphs. What you will learn in this section is, again, construct stem and leaf plots, construct dot plots, and construct time series plots. So the purpose of a stem and leaf plot is when we use quantitative data to sort data quickly into a histogram form to see the distribution. It is also used when we want to do hand calculations for finding median and quartiles. The process is to find the smallest and largest values in the data set, review the first digit of the individual values of the data, and determine a stem set of values. Then draw a vertical line and place the stems in numerical order on the left side of the line. For each observation, place the last digit in the row of the stem of the value next to the observation. Place commas for the next value. So for our example, the following data of ages of an extended family, put the data into a stem and leaf plot. The ages, as you can see, go from 7 until 77. In the example, you will see that the ages, we put the digits for the first digit from 0 to 7. That relates to the 0 position of the digit for 7 and 9, and then the 10s, 20s, 30s, 40s, 50s, 60s, and 70s. As we put the numbers from 0 to 7 down on the left-hand side, you see that we just put the numbers in the correct row for the last digit. So for example, 57 would ultimately go here with a 7 after the 5, and so forth. And so here's our stem and leaf plot. And you can see that it's nicely distributed from the smallest ages up to the largest ages of 77 and 75. So the purpose of a side-by-side stem and leaf plot is to compare two different samples of the same variable type. The process is the same basically as before, except now we have two lines in the middle, and we review the range values in each data set and determine the stem values. Once we have determined, once we've placed the stem values in order, in the center of the diagram we place between the two lines, and the stem values in this case go from 4 to 10, 4 meaning 40 and 10 meaning 100. We put the leaf values of each observation on the corresponding row of the stem of that value, and then we interpret the results. In our example, we have two different classes. We have an English class and a history class. And you can see we have put in the history class, we have put the values for the history class. They start out at 59 is the minimum value and 100 is the maximum value. And for the English class, we started out at 45 and we ended up at 91. Now you can see all of the different values. There's no commas here. Sometimes commas aren't included in the stem and leaf plot. but you can interpret the results. You can see that the distribution for the history class is higher than that of the English class, and that the center for the history class, if we did the average, it's going to be probably around an 80, whereas the average for the English class average is going to be around a 70. So dot plots are not actually presented in this section, but dot plots are used to show the distribution of data sets by frequency of values. It is used to give a rough impression of the shape of the distribution. Note the limitations is statistical calculations can't be made from these graphs like in the stem and leaf plots. So in this next example, we consider the number of children had by each of the U.S. presidents and their wives. You will notice that this is our distribution. Most of the presidents had children less than 8. There was 2 presidents that seemed to have more than 8, here and here, one at 10 and one at 15. And so you can see how the distribution pattern is skewed slightly to the right. Dot plots are sometimes used to indicate outliers, but in the Math 1330 class you will see that box plots are also used to find outliers. Our final graph that you should be aware of is a time series plot, which is not again presented in this chapter, but it looks at 2 quantitative variables in an XY axis, where here the x-axis is the year in which the Dow Jones Industrial Average is being measured, and the average Dow Jones Industrial Average is on the Y variable. And you can see the trends of the ups and downs of the Dow Jones over time, and you recognize the pattern here where we had the major recession in 2007 and 2008. Well, that concludes our chapter 12.2 on organizing quantitative data into tables and into graphs. Our next section, 12-3, is going to discuss means and medians, the centralized ideas of a data distribution.